Hello and welcome to ChemTube. My name is Chakube Paul, your chemistry teacher. In today's lesson, we would be looking at the second part of the classification of matter. In our last lesson, we looked at the first part, where we said that matter can be classified into pure substances and mixtures. We focused on pure substances in that lesson, and we went on to define pure substances. We classified pure substances into elements and compounds. And in that lesson, we went on to define elements and we said some things about elemental symbols. We gave examples of elements and we focused on the first 20 elements. We went on to define compounds as well, and we said some things about the chemical symbols or chemical formula. Okay? In today's lesson, our focus is going to be on mixtures. We would be defining mixtures. We would also be classifying mixtures. We will go further to differentiate mixtures from compounds. And lastly, we are going to look at some methods for separating mixtures into the individual substances that were combined to produce them. Okay. So without wasting time, in chemistry, what do you think a mixture is? Because I know that generally we know what mixtures are. The food we eat is a mixture. When you are baking bread or your cake, you mix things together. So it's a product of what? Mixtures. But in chemistry, what is a mixture? A mixture is basically the product of the physical combination of two or more substances. That is, when you bring substance A and mix it with substance B without a chemical reaction taking place between them, what you have is a mixture. But if there's a chemical reaction involved, then it is not a mixture, rather it is a compound. So I'll go ahead to say that a mixture is the product of the physical combination of two or more substances. Okay? That is to say that these substances are not bounded by a chemical reaction. Now, what are the examples of mixtures that we know? Common examples include the milk that we use in our homes, the cola that we drink, the seawater, okay? Because the seawater is made up of what? Salt and water and other little things that you find in it, little substances that can be seen even with the microscope, okay? Now, we can as well talk about crude oil, which is what? A mixture of hydrocarbons. We can talk about brass, which is what? A mixture of copper and zinc. So there are so many examples of mixtures. Okay? When you dissolve salt in water, it is a mixture because there is no chemical reaction taking place between them. Okay? So these are examples of mixtures. So having said this, what are the classes of mixtures that we have? Okay, we can classify mixture into homogeneous and heterogeneous mixtures. Now, what is the difference between homogeneous and heterogeneous mixtures? Okay, A homogeneous mixture is a mixture that forms a solution. That is, there is a complete mixing of the materials that you cannot tell one material or one substance from the other. Like I said something about the solution of salt in water. When you dissolve salt in water, you cannot say, okay, this is the salt in the water and this is the water. No, because it forms a homogeneous phase. They become uniform. You can't differentiate one substance from the other. But in a situation where you can differentiate or identify one substance from the other, for example, a mixture of oil and water, where you can say, okay, this is the oil and this is the water, we have a heterogeneous mixture, because we have two phases. We have a demarcation between the substances, or we can easily identify them. When you have muddy water is a mixture, okay? But you can see the mud in the water. So that is a heterogeneous mixture. Your Coca-Cola is a homogeneous mixture because you cannot identify the substances that were brought together to make that cola, okay? So you cannot identify the sugar in that cola, but you know that there's sugar in the cola, okay? You cannot identify the carbon in that cola, but you know that there's carbon in it. So that is the difference between homogeneous mixtures and heterogeneous mixtures. Your ability to identify the substances that make up the mixture, okay? That is the uniformity of the substances in one phase, or the demarcation of the substances into different phases. That is what differentiates homogeneous from heterogeneous, okay? Now, if we want to differentiate between mixtures and compounds, how do we differentiate between a mixture and a compound? Basically, we can differentiate them based on the following points. We can talk about composition, okay? We can talk about properties. We can talk about chemical change. We can talk about separation method, or let's just say separation. Okay, how can they be separated? Okay, now let's look at composition, and we can also talk about phases. Let me put phases on top. Phases. Okay, now when we talk about phases, like I said, we're talking about the uniformity of the substance. Now, a mixture can either be homogeneous or heterogeneous. Okay? It can be homogeneous or heterogeneous. But a compound is always homogeneous. Because when you combine two elements together, or some group of elements together to form a compound, you cannot identify each of the elements in that compound because they form one unit, one uniform unit. Like water. If you bring a glass of water, you cannot point out the oxygen in the water. You cannot point out the hydrogen in the water. No, you can't. Okay? But like said earlier, in the case of a mixture is classified into homogeneous mixtures and heterogeneous mixtures. So that tells you that it can have a homogeneous phase or a heterogeneous phase. Okay, in terms of composition, okay, a mixture doesn't have a constant composition. That it doesn't have a definite composition by mass. I'll give you an example. Now, let's assume I want to make a ginger tea and you also want to make a ginger tea. Yes, I could decide to use one tea bag and you can decide to use 2 tea bags. Okay, I can decide to use lesser amount of water in comparison to the amount of water that you would use. Okay, now I could decide to use sugar, maybe 2 teaspoons of sugar in my tea because I love sugar, and you might decide not to take sugar. I mean, you might decide not to add any sugar in your tea, but that doesn't change that tea from being ginger tea when you are done making it, okay? But you can see that the composition varies. 2 teaspoons of sugar, 0 teaspoon of sugar. 1 tea bag, 2 tea bags. That's differences. But in the case of compounds, the composition is always constant, okay? If I decide to react oxygen and water here, okay, and somebody else decide to react oxygen and water in USA or in Canada or any other part of the world, he will still require 2 atoms of hydrogen to 1 atom of what? Oxygen for water to be formed or produced. Is that clear? So there is a constant composition. Okay. Now, in terms of properties, the properties of a mixture is the individual properties or the properties of the individual substances that make up that mixture. Okay? That is to say that whatsoever substance that was brought together to make up or to form a mixture retains its properties. It retains its properties. Unlike in the case of a compound, where the properties of the compound completely differs from the properties of the elements that were brought together to make that word compound. Okay? So in one case, the properties of the mixture is the summation of the properties of the constituting substances. But on the other hand, the properties of a compound is completely different from the properties of the constituting elements or compounds. Is that okay? Great. Now, in terms of chemical change, we said that mixtures are the substances that make up a mixture or the components that make up a mixture are physically combined together. That is to say that there is no chemical change. If there is a chemical reaction involved, then we can talk about chemical change. So in the case of mixtures, no chemical change. In the case of compounds, because the substances or the elements are chemically combined together via a chemical reaction, there is a chemical change. Okay? Is that clear? Now, in terms of separation, because there is no chemical reaction involved, the substances that make up a mixture can be easily separated. They can be easily separated. You can easily recover each substances that were brought together to make that word mixture. But in the case of a compound, for you to recover an element that was part of the elements that came together to make a compound, you need to introduce a new chemical reaction. A chemical reaction, a chemical process must be involved. So these are some of the ways by which we can differentiate a mixture from a compound. Great. Now, let's talk about separation of mixtures. Now, mixtures can be easily separated as stated earlier, but the separation method depends on the nature of the mixtures. For example, we have solid, liquid mixtures. Okay. We have liquid mixtures. Okay. And we have solid mixtures. Now, the methods that is applied towards separating these mixtures, a mixture that is made up of a solid and a liquid, okay, can differ from the method applied to separating a liquid mixtures. So now, what methods can be used in separating solid liquid mixtures? We have filtration, okay. We have what? Filtration. We have sedimentation. Okay. we have centrifugation, and we also have evaporation. Okay, these are 4 different methods. I'm not trying to say that these are the only methods, but these are 4 examples. Now, these first 3 examples can be used in separating a heterogeneous mixture of solid and liquid. In the sense that for filtration, you can use a filter paper to separate what? The solid from the liquid. The liquid passes through the filter paper while the solid is held back. In the case of sedimentation, okay, the solid tends to settle at the bottom of the vessel while the liquid would be at the top, and you can easily what? Decant or pour out the what? Liquid into a different vessel. In the case of centrifugation, we call it forced sedimentation. That is, you apply a centrifugal force which makes the solid particles to do what? To settle at the bottom of the vessel. Okay? But in the case of evaporation, it is used in separating a homogeneous mixture of solid and liquid, in the sense that, for example, we have a solution of salt and water. Now, for you to get the salt, you have to what? Heat that solution, thereby making the water to what? Evaporate, leaving behind the solid crystals of salt. Okay, so these are 4 different methods that can be applied in separating solid-liquid mixtures. Now, if we talk about liquid-liquid mixtures, we have some methods as well. We can use decantation. For liquid-liquid mixtures, we can use decantation. We can use simple distillation, and we can also use fractional distillation. Okay, now decantation can be used to separate a heterogeneous liquid-liquid mixture. For example, oil and water. Okay, you can use decantation to separate that very mixture. While simple distillation can be used to separate a mixture, okay, both simple distillation and fractional distillation can be used to separate mixtures of liquids based on their boiling points. But the difference between these 2 distillations is dependent on the word boiling point of the substances or the liquids that make up the word mixture. We use simple distillation when the boiling points of the liquids that make up that mixture is far apart. Like if you have up to 50 degrees centigrade between them, then we can apply what? Simple distillation. But if the difference in the boiling point is not much, then we have to use fractional distillation. Okay? In industries, what is used mostly is fractional distillation. Now, let's talk about solid-solid mixtures. In the case of solid-solid mixtures, we can use methods such as magnetic separation. And we can use sublimation. Okay, now for us to use magnetic separation, a condition must be met. One of the solid substances that make up that mixture must be attractive to what? Magnetic force. For example, if we have a mixture of powdered limestone and iron filings, the iron filings can be taken out by the what? The magnet. When you bring a magnet very close to the mixture, the iron filings will jump up and get attached to the magnet, while the powdered limestone will remain behind. Okay. In the case of sublimation, for you to use sublimation to separate a mixture of solids, okay, there must be a high vapor pressure in one of the substances. That is, one of the substances or one of the solids must possess high vapor pressure. So that high vapor pressure is what enables that solid to move directly from what? Solid state all the way towards vapor or gaseous state without first transforming into the liquid phase or liquid state. Is that clear? So this is a condition that must be met. Now, having gone through this, we can say we have defined mixtures. We have been able to classify mixture into what? Homogeneous mixtures and heterogeneous mixtures. We have been able to differentiate a mixture from a compound based on what? The composition, the properties, separation, ease, chemical changes, and yeah. Then we have talked about separation of mixture, that is methods that can be used in separating mixtures. In our next lesson, we would likely be looking at the atomic theory. Okay, so at this point, if you have any question, you can ask the question through the comment section, or you can send me an email. If you have other inquiries as well, you can reach out to me through my email, which is always in the description. Okay, if this is your first time of being with us, if you like to be with us in our next lesson, you can go ahead to subscribe to the channel and as well click on the notification button so that you can also be well notified of the new video when it's uploaded. At this point, I want to say thank you very much for being a part of this lesson. Have a nice day. Bye.